Surface area to volume ratio, the villi of the small intestines, by KayScience.com. This is the inside of a small intestine. All of these structures are villi. And these villi have a much larger surface area than these villi here, with a much lower surface area. On the left are normal intestinal villi, and they have a much larger surface area than the damaged villi on the right. These villi are the villi of someone with celiac disease. So someone with celiac disease is going to have a much lower surface area of villi in their small intestine. This represents the villi of someone with celiac disease. We're going to try and work out the surface area to volume ratio of these villi of someone with celiac disease. And we can represent these villi with this block here. This block has a length of 12 centimeters, a width of 4 centimeters, and a height of 4 centimeters. The surface area of this block is 224 centimeters squared. The volume of this block is 192 centimeters cubed. If we divide both the surface area and the volume by the volume, you end up with a surface area to volume ratio of 1.17 to 1. This image shows what normal villi should look like in undamaged small intestines. This is a representation of normal villi in the small intestine. So the surface area of these villi is 210 centimeters squared. And the volume of these villi is 144 centimeters cubed. So if we divide the surface area and the volume both by the volume, you get a surface area to volume ratio of 1.46 to 1. So this is the person with celiac disease. Their surface area to volume ratio of their villi is 1.17 to 1. And this is what is represented like using a cuboid. And if we compare that to someone with normal villi, their surface area to volume ratio of their villi is 1.46 to 1. So they have a much larger surface area to volume ratio. So someone with celiac disease in the villi above have a lower surface area to volume ratio than the person with the villi below, which has a higher surface area to volume ratio of 1.46 to 1. So someone with celiac disease in the villi above have a lower surface area to volume ratio. This means that the villi below are going to be better adapted for diffusion because their surface area to volume ratio is higher. It's question time. Attempt these questions to check your understanding. I'm now going to go through the other adaptations of the villi. We've got another video that explains adaptations of the villi in full. The wall of the villi is 1 cell thick, so has a 1 cell thick wall of the villi. So has a 1 cell thick wall of the villi. This is to increase the rate of diffusion of substances into the blood. The villi has a very large blood supply. The villi has a very large blood supply that carries nutrients away. It's question time. Attempt these questions to check your understanding. Press pause to practice using those key words. The answers will follow. Press pause to go through your answers and make any corrections to your mistakes. Press pause to answer the questions. The answers will follow. And if you're stuck, just re-watch the video. Press pause to go through your answers and make any corrections to your mistakes.